Alice, are you able to read the intro that Sabrina has written? She is putting her child to sleep. I can click on it.
It's so small here. I'll read it out for you guys. So this is something that Sabrina wrote beforehand. So hi, everyone. My name is Sabrina, and I'm thrilled to introduce Meira Ginsburg. I had the pleasure of working with Meira throughout the school year, and it has been a truly rewarding experience. Watching Meira's growth on this journey has been an absolute delight. She has consistently demonstrated intelligence, drive, and creativity. Her eagerness to learn and explore new ideas, particularly her keen interest in quantum computing, has been inspiring. I'm excited for you all to hear what she has to share this evening. With that, I will turn it over to Meira so she can present her project. Congratulations, Meira.
Hi, I'm Meira Ginsburg. I'm in 10th grade, and my project is about quantum computing. Next slide, please. My mentor is named Sabrina Hirsch. She works in cybersecurity. She got a master's from NYU. Now she works for a company called Clear, which does verification using biometrics. And she lives in New York City and enjoys hiking and skiing. Next slide, please. So my project is called Quantum for Kids, and it's a website that teaches children, young adults, and beginners the basics of quantum computing. As quantum computing is a very large field because it involves so many aspects of physics and math and can be very complex at sometimes. So I chose the project because I was interested in this field, but sometimes it's very hard to find appropriate resources for someone not on such a high level. So I wanted to help other people with the same problem. So some of the topics and technologies I learned was how to use HTML and CSS coding. I also took a Python course and a course in quantum computers, and I used GitHub to build my website. Next slide, please. So my magical experience. So some of the highlights I had was definitely building the website, adding the animations and seeing it all come together. So adding some elements that make it more enjoyable to learn and more to make it easier and to see the concepts. Something I learned was patience. Definitely with coding, there's a lot of little details to it. You could be missing one bracket and the whole code is thrown off. So it definitely takes a lot of patience to sit down, try to figure it out, and get everything to come together. And as I said before, one of the hardest parts was finding appropriate resources, which was really the driving factor of my project. Next slide, please. So this is my website. So the first page is a home page, which has all the main topics of quantum computing, and it gives a little description of each one. So my next page is about superposition. So superposition is a quantum property that's vital to quantum computing. So in regular computers, we use bits to store the information, and bits can be in a state of 0 or a state of 1. However, with quantum computers, we use qubits to store the information, and these could be in a superposition of both states. So this concept is shown in this visual demonstration. So the first dot is just solid blue, represents a state of 0. The second dot is pink and represents a state of 1. But the third dot is cut off a little, but it's blue and pink, which represents a superposition of both 0 and 1. So the next page of the website that's going to come up is about qubits. So qubits are what store the data in quantum computing. So qubits are actually made using diamonds sometimes. So in a diamond, it's made of a carbon chain. But when you remove one carbon and replace it with a nitrogen and remove the adjacent carbon, you get something which is called an NV center, a nitrogen vacancy center. And what happens is a quantum particle is able to be trapped in this center. And a quantum particle could be an electron. And the electron could be in two states, spin up or spin down. But since it's a quantum particle, it could be in superposition of both spin up and spin down. And that's why it allows the diamond structure to act as the qubit, because it could be in a superposition of both states. So the next page of the website is about entanglement, which is also another quantum property. So qubits could be in a superposition, right? You don't know necessarily if it's 1 or 0 because it's in a superposition of both. However, when you measure the qubit, it's forced into one state. So when you have a quantum system, because particles are entangled, when you measure one particle, you're measuring all of them. For example, if you have one qubit, that's when it's in spin up, the other could be in spin down. So if you follow that pattern, if you measure a particle in the quantum system and you get that it's spin up, you automatically know that the other particle is in spin down. And the last page of the website is applications in everyday life. So how these concepts and how quantum computers can change our lives. So the first way is optimization. So since quantum computers are a lot more complex and efficient than regular computers, it's able to do greater functions. So if you have a delivery truck that has a very long and complicated route, since the quantum computer is so complex, it's able to give the driver the most direct and efficient route. And another thing quantum computers could do is they can crack the cryptography we use today, which seems a little scary since then our messages wouldn't be so encoded. But how do we encode information? So we use an algorithm, and this algorithm turns the data you're encoding into a complex, unreadable version. And classical computers, since they're not large enough, they can't decode the strands of information. But using Shor's algorithm, which is a quantum algorithm, it said that they would be able to decode these large strands of coded information. However, the quantum computers we have today are not large enough yet to do that. So for now, we're good. Next slide, please. So these are some examples of the code from the website. So this is the homepage code. Next slide, please. This is the CSS code. So the CSS controls all the designs of the website. So colors, fonts, backgrounds, how the images are formed. Next slide, please. And then this is the superposition code. So this is the code for the animation, and this is like the text. Any questions?
This was really, really cool. I have a question on the Zoom. I was wondering if, with your goal of kind of introducing this material to people who don't know as much about this, if you were able to show this to anybody who didn't know about this and what they were able to learn from it.
Not yet, but I hope to do so.
Fantastic.
Dr. That. I didn't focus so much on that. I focused more on like the properties of the actual quantum computer, how it works. But it's just a lot more, I think it's able to do more like research and data analysis than a regular computer, I would say, because it's a lot more stronger than a regular computer. Thank you.